Here's a brief look at the radius tool that I have up for bid on eBay. And this thing was made expressly for a Logan lathe. And by that I mean underneath here, this piece here is 1 3/8 inch in diameter, and it goes down in the cross slide of a Logan lathe. So if yours is 1 3/8 inch, this will probably fit, even though you might have a 10 inch or 11 inch or a 12 inch or any model of them. It has the typical V cut in it, so when you tighten up the bolts, it will pull it down. I added this for stability, and simply that sits across the back of the saddle, and you can tighten it up with set screws on each side. And I'm sure that you can see all the holes in here. There's a ton of them, and on the top side there's not as many, but between these top holes and the bottom holes you can extend this thing way out, pull it way in, and cut many different radii. So I'm not going to include this 2.5 inch 4-way click stop tool post, but I will be listing it on eBay. So this handle will be removed for shipment to keep the shipping costs down a little bit. It simply threads into this aluminum base. So this aluminum block is slotted so it'll accept most tool posts, and it keeps it nice and square having it milled out. Thank you. Alright, what I'm doing right now is preparing this block of beer can cast aluminum for a turning arbor. And I've already pre-bored the hole one size under half, and now I'm getting ready to ream it with a 1/1000 under ream. Alright, I'm not real good at videos, but I'm going to try to keep my arm out of the way while I do this and keep things into frame. So I've machined one side of this. You saw me ream the hole. Alright, and now I have a turning arbor. Alright, and these turning arbors are marked. One end is about 2 thousandths bigger or so, 2.5 thousandths than the other end. So make sure you start with the smaller end. So okay, set it in your press if you got one, and I don't suggest driving them in with a hammer. And press them in until it gets pretty tough. I try to go halfway. There you go. Alright, so now it's ready to go into lathe between centers with a dog on it later. Right, to save you a huge amount of boredom, I didn't record all this, but anyway, we cleaned the machine up because when you take this off, you can have a tendency to get a bunch of crap in there. This particular one, you loosen 2 Allen sets that go into a set of 45-degree pieces that pull this down in. So anyway, we're going to lift this off, and now I have a tendency to machine things very tightly, and basically all I do is cause myself a lot of trouble. But anyway, this will fit in, and it does have to go in fairly straight. And there it is in place. Alright, now when you lock back down these screws, it becomes quite stationary. But due to the length of it, I found that no matter how tightly I tighten these, I still had movement. So I'll show you in a second. Continue on. That's why I put these Allen sets and a saddle to straddle the guide in the back. Just snug them up. You don't have to tighten real tight. Like so. Now the unit's mounted, and it will allow you to swing left and right to cut your radius. Okay, now you can see what I've done. I've got the arbor in place through the material. I've got a dog over here running against my chuck. I've got a center in the chuck and a ball bearing live center in the tailstock. Now, I know you purists are not going to like this, and you know, you would have probably rather use a collet and all that, but this is not that precision. It's just a demo, and also you can get extremely good precision out of putting your non-hardened center in your chuck and then turning your 60-degree point on it. Of course, when you remove it from the chuck, if you want precision the next time, you're going to have to return that. So anyway, I'll get a lathe tool, a lathe bit set up in that, and be back. Alright, believe it or not, what I find hardest to do is find the exact center of this, meaning that if you're not centered, you might run your compound in and you'll cut on this side, but you won't cut on this side. So what I found I do is, you know, you try to get it as close as you can, then simply turn on your lathe and start working the whole carriage left or right and move your compound in and out. So here we go. So right now I'm against my carriage stop on the left, and I go left and right and I don't hit. So I'm going to move the compound in a thousandth or so, and I'm going to do it again. Okay, so now I'm hitting quite hard on this side, and hopefully we're hitting on this side. So I'm real close. Okay, now if you're planning on taking 40, 50, 60 thousandths cuts, this is not the unit for you. But if you want to take a few thousandths off and that's all you need, then this will work fine. As you see, I'm cutting that side, cutting the same on this side, win a couple thousandths. Now you probably can't see it on camera, but there's about a ½ inch in the middle yet that I don't have the radius cut on. This will probably be our last cut. Maybe one more to put a nice finish on it. Okay, and there you are. We now have a radius on there, And I have a formula that I found online someplace. I don't know if it's correct or not. But anyway, it goes by it starts out by foot, so many thousandths per foot. So I broke it down to inch, and this is 1.5 inches, and the pulleys on my 2-inch belt sander are 2 inch, and etc. So, hope that enlightens you on how this is done later. Thank you. I guess one of the things I did forget to show you is that there is a radius, and you should be able to see that by me rocking this parallel back and forth. There's about 12 thousandths on each side, and this will cause your flat belt pulley or your belt or whatever to ride to the center. Thank you.